Polynomials, the factor theorem. When a polynomial is divided by x minus a and we get a remainder of 0, that is, we evaluate the polynomial for a, we get 0, then that means that x minus a is a factor of that polynomial. Now if we just take that back to numbers for a moment, if I did 12 divided by 3, I would get 4 with a remainder of 0, because 3 is a factor of 12, and because it's a factor, there won't be anything left over. There will be no remainder. So when a remainder is 0, we know we've divided by a factor. Now this is really useful because we need to be able to factorize a polynomial. We can already factorize a linear polynomial, or we can factorize a binomial expression, as in a quadratic. But we might want to be able to factorize a cubic, and that means we need to be able to work out the first factor, and next lesson we'll learn to do that, or next video we'll learn to do that using this factor theorem. But for now we're just going to decide if each of these are factors of this polynomial. So we find the remainder, and if it's 0, then our expression x minus a is a factor. So for x plus 1, first step, find the remainder. A is negative 1, so we're going to evaluate p of negative 1. Substitute in negative 1. That's negative 1 plus 1 plus 4 minus 6 cancels. That is negative 2. So that is negative 2, therefore my remainder is negative 2, therefore not a factor. So x plus 1 is not a factor of this polynomial. We'll check this one. A is 2. So I'm evaluating the polynomial for 2. Eight plus 4 minus 6 minus 6, that is 0. Evaluating the polynomial for a is 0, therefore the remainder is 0. So x minus 2 is a factor of that polynomial. So that's all we'd want to be able to do. Check to see if a particular expression is a factor of a larger polynomial. Later on, we'll use that to get our first factor for factorizing.